Hello engineers, welcome to the new video of the course, and in this particular video we are going to understand the concept of slew rate. So this particular concept or this particular topic or the parameter which is present in Opamp, it is very important, and at the same time it is very much underrated as well. So generally if you are designing certain circuit and if you are playing with certain high frequency signal, so it's very important to look upon the slew rate of that particular respective Opamp. Okay. So I'll tell you that why exactly it is underrated, like why most of the people they don't focus upon this particular parameter. Okay, but before that it's very important to understand its definition as well. So we will focus upon the definition of slew rate. So basically slew rate is the thing, but it specifies that how fast or how quick your output is changing. So let me just write it in very short form. It specifies, see, I'm not, if you refer my notes, if you refer my PDF, I don't like to give the exact definition which are present in your book or maybe on the internet. I'll just give my version so that whenever you will refer my PDF, it becomes pretty easier to revise the things and to again regain or to reimagine the things that we had actually covered in this particular session. So let me just write its definition. So it specifies that how fast my output is changing, how fast the output is changing, how fast the output is changing. Okay, so ideally slew rate should be infinite. Or practically speaking, it should be as high as possible. Talking about IC741, so for IC741, the slew rate is 0. volts per microsecond. Okay, so basically this particular slew rate, it is measured in volt per microsecond, measured in volts per microsecond. So it is measured in volts per microsecond. I hope that you are able to understand this particular concept. Okay, now even if you are unable to understand it, don't worry, we'll take one example so that it will be pretty easier for you all guys to understand this particular concept in very easiest way. So for that, let's consider that we have two slew rates. Let's assume that we have two op-amps. Okay, so let me just write over here, and let's assume that we have two op-amps. Okay, two op-amps. The first op-amp has the slew rate of maybe 5 volts per microsecond, and the second op-amp has the slew rate of maybe 0.5 volts per microsecond. So let's assume that the first op-amp has the slew rate of, that is SR1. I'll write it in this way, SR1. The first op-amp has the slew rate of 5 volts per microsecond, and let's assume that the second op-amp, that is SR2, has slew rate of maybe 0.5 volts per microsecond. Okay, and let's assume that we are playing with a buffer amplifier circuit, wherein what we are doing is that, I'll come to this particular point, don't worry about this as well. Yeah, wherein what we are doing is that we are actually providing a square wave signal of 5 volts picked 5 volts. Okay, 5 volts of signal. So this will be plus 5 volts and this will be 0 volts. Okay, so basically we are playing with the buffer amplifier, and at its input side we are providing a signal of 0 to 5 volts, square wave signal, something like this as I had drawn over here. Okay, now let me erase it. Okay, so at the output side, since this is a buffer amplifier, so let me just show one waveform so that it will be pretty easier for you all guys to understand this particular concept logically. So see, this is the signal that I'm giving to the input of the buffer amplifier. This is the signal that I'm giving to the input of the buffer amplifier, something like this. Let me draw it properly. Yeah, so now let me copy and paste it. Yeah, so this is the input signal that I'm giving to the buffer amplifier. So the output signal will be same, right? Same kind of output signal will be getting represented over here. So this is my input signal, okay, and at the output side I'll get this kind of signal, right? This is V out. So at the output side I should expect the same kind of signal, because we all know for buffer amplifier the gain is 1, okay. For buffer amplifier the overall gain is 1, buffer amplifier, okay. So we are expecting this kind of signal at the output of the buffer amplifier. So let me just show over here. So if I'm giving a square wave signal which is fluctuating from 0 volts to 5 volts, so at the output side as well I should expect the same signal which should fluctuate from 0 volts to 5 volts, okay. Now we had not taken slew rate into account for this particular application up till now. Now let's assume that we are doing the same application with the help of two different Opamp, as I had mentioned over here, that is this particular Opamp. Let's assume it has a slew rate of 5 volts per microsecond, and this particular Opamp, it has slew rate of 0.5 volts per microsecond, okay. But before that, just a second, let me just move this particular slide over here. Yeah, okay. So now just come over here, okay. So the Opamp which has a slew rate of 5 volts per microsecond, let's see what kind of output it gives to me. So yeah, you see over here I will get this kind of output, okay, something like this. You will get a certain slope over here, sorry, get certain slope, something like this, okay. Then over here this you will get a constant voltage of 5 volts till this point, okay, and after this point you will get this kind of signal, okay. So you see this is my input signal. It starts from 0 volts, okay, it starts from 5 volts at 0 microsecond until 10 microsecond it is 5 volts, and after 10 microsecond it is 0 volts till 20 microsecond. But you see over here this particular signal at the output side, when it is occurring, it will take certain time, right? It will take certain time. So from 0 to 1 microsecond this signal, it will move till, it will try to move to 5 volts, okay. It is not 5 volts. See, at the input side this particular signal, it is 5 volts, right? But over here it is not exactly 5 volts for 1 microsecond. Why? Because after 1 microsecond, that what is my slew rate of this particular Opamp? The slew rate is 5 volts per microsecond. So after 1 microsecond it will give signal of 5 volts. Getting my point? You see over here, after 1 microsecond it is giving a signal of 5 volts. Similarly, when my signal, it is traveling from 5 to 0 volts, okay, at 10 microsecond. So over here it will travel from 10 to 11 microsecond, and after 11 microsecond it will give a signal of 5 volts, okay, something like this. Similarly, now you just come over here at this particular point at 20 microsecond, my input signal, it is moving from 0 to 5 volts very quickly, and over here it will take some time to move from 20 microsecond to 21 microsecond. So why? Because the slew rate, it is 5 volts per microsecond. So at 1 microsecond, okay, it will take some time to move from 0 to 5 volts, okay. And what is that time? That is 1 microsecond. And you see after that it will be 5 volts, okay, and it will come up till this particular point, and you see the input signal, it is traveling from 5 volts to 0 volts at 30 microsecond. So at 30 microsecond the signal will stop at 5 volts, and it will take a time of 1 microsecond to move from 5 volts to 0 volts, okay. So you see we are not getting an exact square wave, okay. You see there is certain slope over here. Getting my point? Great. Now let's come to this particular Opamp whose slew rate is 0.5 volts per microsecond. So you see over here what exactly we will what waveform we will get over here. So if if at the output side I am getting 0.5 volts per microsecond, so at 10 microsecond what will be its value? So see, it's pretty simple. For 1 microsecond I am expecting the output as 0.5 volts, right? So for 10 microsecond what will be its value? So its value is x, so you just need to do cross multiplication. So x times of 1 microsecond is equivalent to 0.5 into 10 microsecond. So this micro and micro will get cancelled, and what we have essentially is x, which is 0.5 into 10, right? So this is 5 volts, okay. So that means what? At 10 microseconds I will have signal of 5 volts. So that means what? See, what will be the value before 10 microseconds? So what will be the value in this particular area? We don't know, but at 10 microsecond it will be 5 volts. Okay, getting my point? At 10 microseconds it will be 5 volts. I mean the output signal will be 5 volts. Getting my point? The output signal will be 5 volts at 10 microsecond. Okay, but before that we don't know what will be its value. So we are going to represent it in this way, because my signal, it is increasing steadily, right? So I will represent it in this way, something like this. Okay, again if you look over here, from 10 to 20 microsecond, this signal will be something like this. Why? What is the reason behind that? Because this op-amp, it is responding very slowly, or its slew rate is very less. So it will fall, the signal will fall at the rate of 0.5 volts per microsecond. Getting my point? Okay, see, my input is changing very rapidly, but my output is not changing, okay, very rapidly. So you see, what we really wanted at the output side is the same signal, but what we are getting is the triangular signal. So you see, this particular waveform, it is distorted, or the output signal, it is distorted. So we call this particular signal as the distorted signal. Distorted signal. And why exactly it is happening? It is because of the slew rate of the op-amp, that is 0.5 volts per microsecond. Even you see, this is not highly distorted, but still it is, by some amount it is distorted. So it's advisable to use the op-amp of a higher slew rate, okay, whose slew rate is quite high. Getting my point? So that's the reason that this particular parameter, it becomes very important. And generally I had seen most of the students, most of the even faculties, and even most of the professionals, they don't focus upon this particular parameter that much. It is very important. If you don't focus upon this particular parameter, and if you are dealing with certain high frequency signal, so at that particular time, you might get, or in fact you are bound to get a distorted signal at the output side. Okay, and this is like an error. Okay, so this is the concept of a slew rate. Getting my point? I hope that you understood this particular concept. Now, one question that might arise in your mind, that why exactly this particular slew rate is occurring. That means, why exactly we are getting certain delay at the output side. If you see, it's like a delay, right? So if my input signal is moving very rapidly, so at the output side I want that my output signal should also move very rapidly. But what exactly is present inside op-amp? What exactly it is present inside an op-amp which is creating this kind of delay? Okay, so let's go into the internal structure of an op-amp. Okay, so if you see very clearly what all blocks we have, so you can clearly see that we have two input terminals, that is fine. We have one differential amplifier. Now differential amplifier has two transistors, so generally transistors don't create that kind of a delay. Okay, generally transistors don't create that kind of delay. Similarly, at the gain stage we have transistor. Again, transistors, as I said, it don't create that kind of delay. At the output stage as well, we have certain amplifiers and resistors, right, to make sure that my output resistance is very less, or the output impedance is very less. So again, resistance transistors, they don't create that kind of delay. Okay, they might obviously they are responsible to reduce or to increase the voltage, but surely they are not involved in creating the delay, okay, or adding the delay. But if you look at this particular parameter, what is capacitor? Capacitor. So capacitor is a device which holds charge, which holds or which releases the charge, right, or basically which holds the charges, right. And when it comes to capacitor, so one thing that we know about capacitor, and that is capacitor, it takes some time to charge and discharge. Capacitor takes time to charge and discharge. Okay, and why exactly this particular capacitive circuit is present? So basically it is present for the internal compensation, okay, to enhance to enhance the stability of an op-amp at a higher frequency. I'm not going in that domain, but generally it is required to maintain the stability of an op-amp at the higher frequency of the signal. Okay, so this capacitor which are connected internally, they take certain time to charge and discharge, right. And due to this particular phenomena, the concept of slew rate is introduced. So due to due to this phenomena of charging and discharging of capacitor, the concept of slew rate, the concept of slew rate is introduced in an Opamp. I hope you are able to understand this particular point. Again, we will quickly revise the concept of slew rate. So when I started this particular topic, this is the definition, a random definition that I had provided, that it specifies that how fast my output is changing with this output is changing. Okay, so its formula is dV by dt. So obviously, if something is changing, so there should be some another parameter which will tell us that okay, so this particular parameter is changing with respect to that particular parameter. So how fast my output changes with respect to time. So it is given by dV by dt. So we actually take the slope, right? Slope. You see over here, this is my slope. This is my slope. How fast my output is changing, right? How fast my output is changing. Similarly over here, if you look very clearly, it is not a straight line. This particular line, it is something like this, right? Something like this, from 0 to 1 microsecond. So it is taking very less time to travel from 0 to 5 volts. Okay. On contrary, you see over here, this slope, it indicates that it takes very high time to travel from 0 to 5 volts. Getting my point? So that's why we generally prefer to show it in this way, that is dV by dt, dVO rather, output voltage, since we are dealing with output voltage, right? So for IC741, it is 0.5 volts per microsecond. Okay, so this is how we actually show. So sometimes, you know, in maybe in your question paper on, you know, few of the books, they show it in this way, dV by dt. Okay, it is nothing but slew rate. Okay, so to understand this particular concept in more detailed way, what we had done over here is that we had actually take two Opamps. So one Opamp has the slew rate of 5 volts per microsecond, and the another Opamp has slew rate of 0.5 volts per microsecond. And then we had just taken one application of an buffer amplifier, wherein we are trying to introduce this particular concept of slew rate. So when we do so, what we get is this. So this is my input signal, which is traveling from 0 to 5 volts. So at 0 second, it is 5 volts, and at 10 microsecond, it is 0 volts. At 20 microsecond, it is 5 volts again, right? So what I want is that, since we are dealing with buffer amplifier circuit, so at the output side, I should get same signal, right? But you see over here, the concept of slew rate is getting introduced over here, and you see from 0 to 5 volts, you know, it is taking around 1 microsecond, and after that it is 5 volts. Again, from 5 volts to 0 volts, it is taking around 1 microsecond to travel. Okay, so this is the traveling time. So you see, we are not getting an exact similar signal, but it is somewhat same, right? We are not getting an exact square wave, but you can assume that it is a square wave, because you take any Opamp, it doesn't matter how precise or how stable it is going to take some amount of time to go from higher voltage to lower, or from lower to higher voltage in that case, right? So we can say that it is almost similar, or it is almost equivalent to a square wave, but it is not exactly a square wave. Getting my point? Great. Now coming to this particular Opamp, whose slew rate is 0.5 volts per microsecond. So you see over here, from 0 seconds to 10 microsecond, it is taking a time, right? It is taking a higher amount of time to travel from 0 to 5 volts, right? In fact, you can check over here. I just done a calculation. If in 1 microsecond, it is traveling 0.5 volts. So at 10 microsecond, what will be its voltage? So we just did a cross multiplication, and what value we get over here is 5 volts. So you just have a look over here. So at 10 microsecond exactly, we are getting a signal of 5 volts. Okay, but before that, it will travel in this particular way, right? So you see, this particular signal is a distorted signal, because this is not the desired signal. Our desired signal was this was our desired signal, but we are getting this kind of signal at the output side, which is an absolute error, right? So this is like an error. Okay, So that's why this particular concept of slew rate, it becomes very, very important, and this is the most underrated, but it is the most important concept in an op amp. Getting my point? So henceforth, if you are working with op amp, just make sure that the op amp that you are using, it should have a higher slew rate. Okay, ideally infinite, but practically it should be as high as possible, maybe 5 volts per microsecond, maybe 6 volts per microsecond, something like that. Okay, getting my point? Great. Now, yeah, another thing that we had learned over here is that, why exactly this slew rate came into existence. The concept of slew rate came into existence. So what we saw was that in the internal circuitry of an op amp, we have certain blocks, that is differential amplifier, gain stage, output stage. But what we saw was that all of these particular stages has either capacitor, has maybe either resistances, right? Okay, so all of these things, they are responsible to either increase or decrease the voltage levels, right, to play with the currents. But when we specifically talk about the capacitor or the capacitive network or the capacitive circuit, what we really know is that this particular block, it is responsible to, to hold the charges. So basically capacitor takes time to charge and discharge, right? Takes time. So you see this particular factor time is getting introduced because of this particular capacitive network, right? So due to this phenomena of charging and discharging of capacitor, the concept of slew rate is getting introduced into an op amp circuit. Okay, and that's why the slew rate is getting introduced, because of this particular capacitive circuit. And I really hope that you understood this particular concept in depth. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I will be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.